certain number of elements in it. Okay. Yes, for each technique, we are having different methodology to be followed. For different method, different time taking will be there and different space will be allotted. For every method, it need not be same. So look at the time complexity for the different sorting techniques. For any kind of algorithm, if you want to do any sorting, it will take big O of n square because n is the size of it. So that number of elements, I'll just stop sharing once and I'll share it again. Some pop-up window has been came into it. So I'll do it again. Yes. Are you able to see the screen fully? Now, in order to sort number of elements n, the time complexity is big O of n square. Naturally, maximum time complexity. If I use the method in a different way, the time complexity will reduce it to n log n by some other method. Like that, I can change it to big O of n also. Depending upon the methodology which I am using, I'll be reducing time complexity. For by bubble sort, selection sort, and insertion sort, we are having the big O of n square. So we are looking into the insertion sort. What is the meaning of it? What is the method included in it? We look into it detailing, right? So please put the subheading insertion sort. In the insertion sort, what we will do means we'll take the first element in the list is already sorted and we'll begin with the second element. And if the second element is compared with the first and swapped, if it is not in order, the process is repeated for all the subsequent elements. What is that means? I'll not consider the first element. I'll go to the second element. Until what I'll be comparing? Until I reach the first element, including the first element, I'll be keep on comparing. If it is less, I just swap it. Swap in the sense, I'll just move the smaller element to the left side and larger element to the right side. Like that I'll be doing. If it is not the case, that means if it is not small, if it is big, I'll save it as it is. Like that, the process repeats until all the elements in the list was compared. Right? This is what the insertion sort. I'll just explain the method in an example. Please look at here. Suppose if you take 10, 2, 6, 15, 4, 1, according to the method, I should skip the first method. That means first is already sorted, we should assume. So I'm starting it from the second. And second is less than the 10, no? So I'll swap those two. I'll interchange the position of second element to the first and first element to the second. And I'll repeat the process. So now the next second element after what is that? 6. So from 6, I should start the comparison. So I'm comparing 6 with 10. Even 6 is less than 10. So I'll swap 6 and 10 position. Then I'll compare 6 with 2. Is it less? No. So I'll come out of that for loop. That repetition of the loop got false. That second element is not less than the third element. So I'll come out of it. Now I'll go with the fourth element. 15 will be compared with 10. Yes, 10 is less. I won't swap it. 15 will be compared. I won't compare the subsequent element, ma. I'll compare it with the element with which index I am using here. So A of j will be compared with the A of I every time. And I will lead to the 0. J will be checking the condition that I greater than or equal to 0. Right? So 15 less than 10 means then only the swapping will be done. That means A of j less than A of I means there will be a swapping. If not, there will be no swap. Just to decrement the I and j. Right? So I have decremented the I but not the j. Then I am comparing 15 with 6. Even 6 is less. I won't compare. 15 with 2. I won't compare because it is already less element is there. That means it is already sorted. No need to go ahead. So next I will be considering the next value, that is 4. 4 will be compared with the 15. Yes, it is small. So I'll swap it. Next. 4 will be compared with 10. Yes, even that is also small. 4 will be compared with the 6. Yes. Then please swap 4 with 2. No, this is not possible. So swap with 4 and 6. Here is the list. Next, please compare 59.1. Yes, small. So decrement the I. 1910, small. So decrement the I. 196, small. 194, small. 2 and 1, small. So please swap it every time. 15, 10, 6, 4, 2, then 1. This was the final sorting which we got it by using the method insertion sort. What is insertion sort? Making one empty space and inserting that value into it by changing its position. Okay? Repeat the process. So this is what the method. Please look at the method. First of all, here is the method for the insertion sort. Initially, I am taking the starting element A of 0 as the key. Then I taking J index as I minus 1. J greater than minus 1. That means up till the 0th index only I have to perform. Beyond the 0th index, is there any element for me? No. And I have to compare A of J should be greater than your key. Then only I need to swap it. If not, I should not swap it. Right? So here is the thing. And then A of J plus 1 into that index, your key should be assigned. Right? This is what the method. And this is what the print array in order to achieve your insertion sort. Did you understand this method? So here I told you we are doing the program with the help of your Java software. So you need to save the file with the Java dot extension. Then for running Java space file name. Then before sorting, this is the elements. After sorting, these are the elements. And after every iteration, I've taken one printf in the condition. So it is printing me every time. What is the flow what performed in the insertion sort? That will be shown in this output. Are you comfortable with this? Here are the outputs every time which is compared and what is the elements after sorting. And this is what the thing. And here I am repeating the number of elements for n iterations. So the time complexity is big O of n square. This is not the best. This is not the best algorithm to perform the sorting technique, ma. We had the better one than this. So we look into that. But meanwhile, this is one of the methods suggested by one of the film. Right? Best case time complexity. Already the list is in the sorted order. Is there anything to repeat the statements? No. In that situation, I have to check each and every iteration. No. So big O of n. If it is average or worst case, it is big O of n square. Okay. Maybe partially sorted or fully unsorted. Then in the both the scenarios, the time complexity will be big O of n square. This is what about the insertion sort. In the insertion sort, what is the method you have implemented? We have skipped the starting element. We have repeated the process from the second element and we have compared it with the previous element. If it is small, we are just shifting it. If not, we are just staying back into its position. That means we are making some space for the element into its appropriate position and then we are placing it. This is what the insertion sort. Yes. The next topic is shell sort. Please look at here. This shell sort is very simple and easy. It's just like your insertion sort only. But it makes some small difference among it. If you learn that difference, it is very easy. So shell sort, we are trying to implement it with the help of the insertion sort algorithm only. It belongs to the group of very efficient algorithm. When compared with the insertion sort, bubble sort and selection sort, this shell sort is a bit better. The algorithm breaks the original sets into small sets and then it performs insertion sort for that small set. After that, then merging the neighboring subset, it will form the overall array again back. So how you are going to divide it means? It depends upon the user. Depending upon the array size, he might be dividing the subsets into maximum. He will be taking 2 or 3 or 4. If the array size is 50, he will be taking either 5 or 10. Like that. As much less size of your subset, that much will be your sufficient time complexity will be very less. Okay. Here is the example. to sort the 9 number of elements, and we are taking each subset with the 3 elements, right? Please look at the example. I've divided it. Yellow, green, white is one set. Yellow, green, white, yellow, green, white. Are you able to follow me? Then what is our insertion sort? First, we need to pick the first element, skip it, then compare the second element. All right, 15 less than 41. So please swap 41 in the place of 15 and 15 in the place of 41. Right? After that, please skip to the next element, that is 82. What is your list now? 15, 41 and 82. 82 is greater than that. No need to skip it. Even 15 is also greater than that. No need to skip it. So the first list got sorted. How it got sorted? 15, 41, 80. Later on another list, even that also we need to sort it. I'll show you stepwise. Please look at here. Stepwise, I have sorted the first element. Then after the second element, first element should be skipped. I have to compare it with the second element. 43 is greater than 32. No need to swap it. Then I'm comparing with the third element. 19 greater than 43? Yes. So please swap it. Then 19 greater than 32? Sorry, 19 less than 32? Yes. So please swap it. So how your list will be now? 19, 32, 43. Right? Then after, please, the last list is 41, 65, 82. They are already sorted. So now compare the subsequent parts of it. First part and second part, then followed with the third part. In the first part, if you consider, it will take the elements of the insertion sort again. So first it will pick the element 15. Sorry, it will avoid the 15. It will be taking some 43 and it will be comparing with the previous element. So what is that element? 8. It is less than that. So it will be swapping. Again, it will be compared with 5. No, the condition is false. It will come out of the loop. Like that, the process continues to submerge all the subparts which you have taken for your process. So in the terms of your 32, 19, 43 and 41 will be the subset 2 and 3. But 41 should come first. So it will compare with it and they will take the appropriate swap for it. So finally, the list will be 5, 8, 15, 19, 32, 41, 43, 65 and 82. This was the method. So what is the concept we need to learn in this shell sort? First, we need to divide the shell sort. Sorry. First, we need to divide the list into some subparts. It must contain at most 3 or 4. It depends upon the end user. Once you perform the division of the subset, then please apply the logic of the insertion sort. What is the insertion sort? Please compare the list with the previous element. If it is small, swap it. If not, please merge the list among them. Okay? Here is the logic for the shell sort. First, we are dividing the list. Then we are performing the appropriate insertion sort is written over here. Right. Please take the gap of it. Okay? Here is the main function from where we are providing the list and where we are calling that function shell sort, and then after that printing the array. Okay. Then the very, very important topic, merge sort. This is also one of the sorting techniques where it follows with the principle like divide and conquer. Divide and conquer meaning means divide first, then solve the problem. Don't take the big problem as it is. First try to divide it, then solve the small pieces from that. This is what the strategy it will follow for the merge sort. Right? Always remember, merge sort will be following from top to bottom methodology. Previously, up till now, we have seen the bottom-up approach, but it was a top-down approach. Here is one example. Are you able to see this example clearly? Yes. Yes. Just decrease the size then. Okay. Yes. Here are some values. What are those values? 14, 7, 3, 12, 9, 11, 6, and 2. Are they in the sorted order? No. So what is the technique of merge sort means? Merge means what? Combining, right? So here first we need to divide the list. Until we can't divide it, we have to divide it. Then start recombining it with condition. What is that condition? How we are going to do? We'll see in the example. Okay. First consider the list. Please divide it into 2 halves. Again, pick the first half. It is a recursive function call. Please pick the first half. Start divide it into 2 halves. And again pick the first half from that. That is 14 and 7. Please divide it into 14 and 7. How? Now, this is the single division element. Are we can divide further? No. So what I'll be doing? I'll be splitting it successfully. Now I'm just combining it. How I'll be combining? This is one element and this is another element. I'll compare A of I with the A of J. If A of I less than A of J means I won't swap it. If the smallest element is in its position, then I won't swap it. If it is not the smallest element, then I'll be swapping A of I and A of J. That means 7 and 14 will be swapped over here into an arbitrary array. Where they will be swapped? Into an arbitrary array. So A array, this is a B array. A of I will be compared with A of B of J, and this will be stored back. That means if the condition is true, that means A of I greater than the B of J, then into the C of K, I'll be storing B of J first. Then after I'll be storing A of I. So 7 will be stored first, then the 14. Then the next function called recursively, where it will be going? For 3 and 12. So under 3 and 12, they are sorted. So into the arbitrary array, it will be stored 3, 12. So overall, what it is stored? 7 and 14, 3 and 12. So 2 subsequent parts are there in the divided mode. So that I need to sort it now. So first I'll be comparing 7 with 3. Yes, 3 is small. I'll store 3 into the arbitrary array. Then 7 will be compared with the 12. Yes, it is small. 7. I'll be storing it. Then please increment the 14 to 14. So 14 will be compared with the 12. Now 12 is small. Please store 12 into the arbitrary array. Then the 14. So how the values are stored? 3, 7, 12, 14. Like that, the left part is got sorted by using the merge sort. Now we are going to move to the right part. Under the right part, what is the first element? 9 and 11. They are sorted. 6, 2. They are not sorted. So I'll be changing it to 2, 6. So the list finally is 9, 11, 2, 6 is the list. So among 9 and 11, I'll be comparing 9 with 2. 2 is small. So 2 will be moved to the arbitrary array. Next, 9 will be compared with the 6. 6 is small. 2, 6 got moved. Then 9, 11 will be occupying. So what is the right side modified list? 2, 6, 9 and 11. Right? So here is this. 2, 6, 9, 11 are the list which got merged back. Now I'll be comparing 3, 7, 12, 14 with 2, 6, 9, 11. How I'll be comparing means I'll be taking this subset as an A array, this subset as a B array. I'll be storing it into the some arbitrary array. So I'll be comparing A of I with B of J. 3 less than 2. No. So I'll be changing this B array to the auxiliary array. So first I am copying it what? 2. Then I am comparing 3 with 6. 3 is small. So I'll copy. Then I'll just increment it. Now 7 will be compared with 6. 6 is small. 6 will be copied. Now 7 will be compared with 9. 7 is small. 7 will be copied. Then 12 will be compared with 9. 9 is small. Then 12 will be compared with 11. 11 will be copied. 12 will be compared. No more elements. So 12 and 14 will be saved back to the auxiliary array. From the auxiliary array, it will be saved back again to the original array, whatever you want to take it. So this is what the method of your merge sort. some auxiliary memory is required or some temporary memory is required to store all the values in the sorted order. And this technique is a bottom-up approach, not the top-down method. Remember this. And its time complexity in all the cases, whether is it best case, worst case, or average case, whatever the method might be, its time complexity will be big of n log n. Did you understand?
Yes.
Okay. Please let us look into the logic now. Okay, I did not copy it. Later on, I'll show it, ma. Okay. Are you comfortable with this mud chart?
Yes.
Okay. The next one is quicksort. Even this quicksort follows the same strategy of divide and conquer, but it is a bit efficient than the mud sort because it performs different logic. It won't take the extra memory or it won't take any other support. It will be dividing among itself based upon one single element. It will keep on dividing the values. What is that single element? I'll just give you, ma. So first of all, quicksort, we need to take one pivot element. Pivot element, right? Different people will choose different pivot elements. By splitting of the pivot element, the algorithm time complexity will be depending much. So most of the people, they'll be considering the first element as their pivot element, right? And based upon this pivot element, all the less elements will be kept on the left side. All the greater elements are kept on the right side. So it depends upon the user pivot element chosen. So how it will be done? Let us see with this example, right? Okay. Here is the list which is unsorted. The numbers are 56, 23, 93, 17, 77, 31, 44, 55, 20. These are your list. And this is, we are doing by using the method quicksort. So already I told you that we need to pick one element as a pivot element. So I picked in this example 54 as my pivot element. So what is my pivot element scenario? What it will be checking after the one iteration? It will take my pivot element into its appropriate position, and the less elements than the pivot will be towards its left side. The greater elements than the pivot will be towards the right side, right? So first of all, if I take 54 and I'm comparing it with the 26, is it less or greater? Less only, no? 26 is less than this. Yes or no? Yes, ma. 26 is less than the 54 or not?
Yes.
Yes. So I'm moving towards left. If I encounter the greater element, then I won't move it. If it is less, I'll be moving it to the left. So 54 greater than 93?
No.
No. So I won't shift towards my left. Now I'll be coming it from the right. ఇక్కడ గ్రేటర్ ఉంటేనే రైట్ సైడ్ మూవ్ అవ్వాలి. ఈ ఎలిమెంట్ గ్రేటర్ ఉండాలి, రైట్? 54 is less than the 20. 54 less than the 20? No. So I won't shift to the left. So here we need to keep in mind two scenarios. If my left mark less than the right mark means there will be a shift among the left-right positions. Left mark less than the right mark means there will be a swap among the left-right position values. If not, there will be a swap among the pivot element and the right mark, right? So remember the method this side. Now in this scenario, here 93 is not less than the 54, so I am not moving my left position. And 20 is not greater than the 54, I am not moving the right position. So my left is at the 93 and my right is at the 20. So now there will be comparison between the left mark and the right mark, because both the conditions are false. Next condition is if left mark less than the right mark, then what I have to do? There will be a swap between the left and right. So there is a swap between the 20 and 93. Now start comparing the condition again. Is 20 less than the 54? Yes, increment the pivot, increment the left mark. 17 less than the 54? Yes. Is 77 less than the 54? No. So I won't increment the left mark. Now compare this 93. 93 greater than the 54? Yes. 54 greater than the 50, 55 greater than the 54. Please decrement the right mark. Now 44 greater than the 54? No. So please don't increment. Where is your left mark? Under 77. Where is your right mark? Under 44. Is left less than the right or not? Yes, it is less than the right. So there will be a swap between the left and right. So 44 and 77 got interchanged. Right? Now we will be comparing. After interchanging, I'll be comparing 44, 54. Yes, they are less. So increment it. Then the value, what is this value? I'm unable to see. So the next value is 31, 31 less than the 54. Then also I'll be changing the left position. Now, please look at this. Please look at this scenario. I'll be just zooming once. Yes, once I come over here for 31, then is 77 greater than the 54? Yes, right mark will be moved. In this scenario, left is not less than the right. So my condition is false. There will be a swap between among the pivot element and the element where the right is. Okay, pivot element and the where the rightmost element is less. So there will be a swap between the 54 and 31. 54 and 31. That means 54. After performing the first operation, the pivot element will be placed into its appropriate position. Please look at here with the example 54. If it has to be in the sorted order, where it will be under position? Under your 31 position. That was made over here by the first iteration. So like that, now it will take the next iteration for the left part of your pivot and the right part, because pivot got placed into its appropriate position. No? So the next iteration will be continuing from 0 to right position, then right position plus to left position. So it will keep on repeating the process like that. Okay. Next two halves it will be considering. Here, look at here. Less than 54 will be on the left side. Greater than 54 will be on the right side. Now we will be taking the left part of the pivot and the right part of the pivot and perform the operation back again. Continue the process. What is that process? Please consider the left part. Please pick the first element as the pivot element. Start comparing it with the second element. If it is small, please move the left pointer. Small. Please move the left pointer. Small. Please move the left pointer. Small. 44 is smaller than the 31? No. Please stop the left pointer at 44. Now please take the right pointer now. 44 greater than 31? Yes. Decrement. 17 greater than 31? No. So there is a swap comparison. Left is under 44 index and right is under 17 index. Is left less than the right to interchange the left-right positions? No. So I have to interchange the position now 31 and 17. So the list is 17, 26, 20, 31, 44. Now after the first iteration, did you find the list in the sorted order? Yes. I think this is what the analysis of your time complexity, ma. So the list finally will be like this. I'll take one Word document and just I'll repeat the process. Yes. Please look at here. Once it is done, the sublist will be 17, 26, 20, 31 and 44. Less than the 31 will be 17, 26, 20 is one list. Again, 44 is another list. 44 one single list, no, it will add up into the list only. So it won't be further sorted. So what could be sorted again? 17, 20, 17, 26, 20. These three elements will be sorted. So considering 17 as a pivot element, comparing it with the 26, not less than that. So I won't move the left pointer. I'll take the right pointer, 20 greater than that. So I'll make a swap among the 26 and 20. So 17, 20, 26. It's already sorted. 31, 44. Next, coming back to the right pointer, that taking 77 as a pivot element, comparing it with the 55, small. So shift it to the right. 93 less than the 77, wrong. So no more left movement. 93 greater than the 77. There is a decrement in it. Here left right was not, is less than that. So there will be a swap among the 55 and 77. So 55, 77, 93. Overall, by merging all these things and grouping under them, we'll find the sorted order. So the time complexity of it also, for best case, it is big of log n log n. Average case is also big of n log n. But whereas in the worst case, completely in the reverse order means, again it will go into big of n square. Are you comfortable with this quick sort?
Yes.
Oh. These are the different sorting techniques which you have to follow into it. And meanwhile, I'm giving a small assignment question to you, that try to sort the elements of type string by using the shell sort. Shell sort code, you write it for the string data type, not the integer or character or float. Try to implement it with that. Okay. And remember the methodology, that every time merge sort will follow, quick sort will follow which strategy? Divide and conquer strategy. Whereas selection sort or insertion sort or bubble sort will not follow any strategy. Directly they'll keep on sorting the elements. Okay. The comparison will be done from left to right, and almost all the sorting techniques will be done from the top to bottom. Whereas merge sort will be doing it from the bottom to top, because it has to divide the element in the least possible division part and then start merging to the top back again. So only merge sort is called as the bottom up approach. And what is the strategy it follows? Divide and conquer. And what is the time complexity of it? Big of n log n for all the cases, whatever the list might be, whether it is sorted or randomly given or fully unsorted also. The method is divide it until the least possible division and then start merging it from the bottom by comparing. So whatever the list might be, that's the reason this is the only algorithm where all the possible time complexity will be same, big of n log n. Whereas for the other algorithms like selection sort, bubble sort, merge, quick sort, shell sort and all, the time complexity will be varying depending upon the input, if it is half sorted or full sorted or whatever it is. Depending upon that, it will be varying. Whereas in the merge sort, for all the cases, the time complexity will be big of n log n. This is the very, very important point you need to remember. The special points about the merge sort. Merge sort is a bottom-up approach, and merge sort is an example to take the scenario that it follows divide and conquer. And this is the only algorithm where all the possible time complexities will be same. Average, best and worst time complexity will be big of n log n. Suppose if I take such kind of elements like, one second, ma, I'll share one small Word document for repeating the process of your merge sort again. So let me. Now you guys have to tell me what is happening over there. suppose if I take some random elements, this is 8 mark. Randomly I've taken some elements. Yes, how many elements I've taken? 8 elements. Okay. I just want to perform the merge sort now. Before performing merge sort, what it will do? It will divide the list into 2 halves. That is 17, 23, 56, and 7 is one list. And the other list is 45, 89, 8, then 77. This is what one first step of it. So recursively again it will take the picture. So again what it will take? 17 space 23 is one list and 56, 7 is another list. So on the right side it will take 45, 89 into one list and the other possible list is 8 and 77. Among them, further also I can perform the division. So further division is 17 is one list, 23 is another list. Yes or no? They are partitioned now. Even here also 56 is under one list and 7 is under another list. Further division was done. They are individual elements now. So 45 and 89. Then after, Then after 8, 77. So further possible division was done. That means no more further division I can't do because they are the single elements. Now I'll be just comparing the first subset of it with the second subset of it. Which is small, I'll be placing that into the list first. But here in this situation, 17 is less than 23. So into my new list, I'll be placing 17, 23. Once I perform this, I'll come back to this 56 and 27. So among them, 56 will be compared with the 7, which is small. So 7, I'm writing 7, then the 56. Like that, next sublist is 45 and 89. They are already sorted. I'll be writing them in the sorted order. 8 and 77. Even they also are sorted order. So I'm writing them as it is. Now, this first subsequent elements will be swapped out first. So what is that? 17 will be compared with, first sublist is 17 and 23. The second sublist is 7 and 56. So first these two will get merged. So how they are going to merge? 17 will be compared with the 7. First sublist, first element will be compared with the second sublist, first element. So 17 will be compared with the 7. Among them, 7 is the small. So next sublist will be 7 first. Then here the index got incremented, whereas in the first list, it is not incremented because still it is with the first element only. Next, I'll compare 17 with 56. Among them, which is small? 17. I'll add up that. Then the increment in the index, 23 will be compared with 56. 23 is small. So add it, then compare it with the, no more comparison is possible. The left out elements I have to add up into the arbitrary array. So this is what the sub part of your left side. Then the right side. Coming back to the first sublist 45 and 89. And the second sublist is 8 and 77. Among them 45 will be compared with the 8. 8 is small. So 8 will be added to the list first. Next 45 will be compared with 77. Among them 45 is small. I'll add up into it. 88, 89 will be compared with 77. 77 is small. Then 89. This is what the sublist 1 and sublist 2. Now I need to merge these two sublists. How can I merge it? First I'll be comparing 7 with 8. 7 is small. So I'll add up here. Then I'll take this 17 with 8. 8 is small. So I'll add up 8. Then 17 will be compared with 45. 17 is small. Then 23 will be compared with 45. 23 is small. 56 will be compared with 45. 45 is small. Then 56 will be compared with 77. 56 is small. Then the left out elements are 77 and 89. Okay, this is what the final is, what we have obtained by using the mud sort. Okay. Are you comfortable with this method?
Yes, ma'am.
Okay, ma'am. These are the first sorting techniques which you had in your syllabus. So, if I start the next algorithm, no, the time will not be sufficient. Do you have any doubts?
No, ma'am.
Can I start the sorting to in the next class? That is tomorrow.
Okay, ma'am.
Sorting 2 and graphs and some dictionary part was the dictionary, or according to your syllabus, what is it? Yes, sorting 2, searchings and graph. Okay, we'll continue it in the next class, ma. Thanks for your time. If you have any doubts, please try to ask me. If you don't have it, you can leave. Yes, any doubts in the previous topic? No? Yes. Try to practice the methods with different examples, ma. Take different data types and continue to try to analyze them. Okay? If you don't have any doubts, you can leave from the class, ma.
Thank you.